Hello everybody, welcome to my channel. Today I'm going to show you how to plot heat maps with genotype ranking and methane package using our software. So let's start our business by running the methane package, and this way so I'll type this and submit to our studio. Then for the sake of this tutorial we will use data underscore g2, which is the design is, as you can see here, it is let's run again. Here is the data, and as you can see there is a different environment, A1 up to A4, which is total 4 environment or 4 location, and 10 genotypes and 3 replications. Also design is randomized complete block design, and starting from the column 4 up to column 18 are the response variables. So if you want to create a plotted map uh, with genotype ranking, you have to use the WASP function. And WASP function, it is a weighted average absolute score value. And if you need detailed information about WASP, it will give you um, this result. Yeah. So how you can calculate the weighted average absolute score, for example, here is, and again there is a number of modules, around 6 modules. Yeah. So I'll show you in the next tutorial how to specify 6 different modules, especially the mixed modules. Then so you have to use the WASP function, and again you have to provide the data name. So in our case our data name is data underscore g2, and inv means this indicate the column that contains the environment. So in our data is designated by env in capital, so this is the environment. Then the genotype gene means the column that containing the genotype. So in our data, genotype represented by capital GEN this way. Then the similar way, the replication means it is the column that contain the replications. So in our data, it's found in this form, which is REP in uppercase. Then here the response variable. For example, if you are interested in dealing all response variables that we have, for example, as I mentioned before, we have around 14, I mean 15 variables, or 50 response variables. So if you want that one, and instead of writing here ph or particular response variable, you have to say everything. So R will run for all response by including all response variable. And again here you have to use this function, this pipe function, and help us again. This function helps us to observe the stability as well as the mean performance. And again, if you are interested on this, or if you have any question, or if you need more clarification, you have to type this one and submit to our studio. Then it will give you this detailed information about it. So WSNP, which stands for the weighted between stability and mean performance. Then I assign you this name as model, or you can give any name that you want. Let's say here K. Then submit this one, and it will give you these p-values for the likelihood ratio test of the analyzed traits. So in our case, it is obvious for the plant 8. But if you write here all the response variables, it will give for all response variables that you feed into our software. Then the first step is we change this name from model into K. So the first one, it will show, if you run or if you hit this card, it will show you the genotype ranking that depend on the number of principal component axes that axes that's used for estimated for the weight average absolute scores index. So you can assign a name that you want here, then plot is equals to k. Then let's run this thing. Yeah. So as you can see here, the heat map is created on the base of the principal components. There are three principal components. The first one is principal component 1, principal component 2, and principal component 3. And here the genotypes in the y-axis, and again here is the legend. So by this way, you can create heat map for ranking of genotype on the basis of their principal component axis. The second one is, for example, if you want to create heat map that indicate the genotype ranking depending on what. The first one is depending on the number of principal components, but here is depending on in the weight absolute score value to the GY ratio. So if you want that one, you have to feed his type is equals to 2. So you will get, we can use this name, okay, yeah. So let's feed this one, then let's run. Yes. So again, it's ranking the genotypes on the base of the WASP to GY ratio. Here is the genotype, and here is the ratio. For example, here is 100 to 0, 95 to 5, and 90 to 10, 85 to 15, and continue in this way. And as reverse, here is 0 to 100. It starts from 100 to 50, and it's decreased in this way. So this is about ranking genotype on the base of the weight average absolute score to the GY ratio. So if you want to display both plots in one column, you have to use this one. Then both genotype ranking on the base of the number of principal components and on the base of the weight absolute and the weight average absolute score ratio to GY ratio. So this is all about today's tutorial regarding to ranking of genotype on the base of principal component analysis and weighted average absolute score using Heatmap package in our software. Thank you for watching. Have a nice time.